in balancing ionic equation. It is not only this kind of equation you meet up with always in your life. You one day meet up with an ionic equation that you may want to balance. Let's take, for instance, suppose you are given zinc plus nitrate to use zinc plus NO2. Let's say zinc is 2 plus. Now look at this equation. This is the equation. Suppose you are given this equation and you need to balance this equation. The first thing you have to do is to identify the reduction reaction and the oxidation reaction. Reduction is one element gain elation, and oxidation is one element loses elation. And when a particular compound or element is reduced, it means that it has lost electrons. And when a particular compound or element gain electron, it means that it has been oxidized. Now, how do you know? Any element in the free state has zero oxidation number. So Z here is 0, Zn here is 2 plus. Now, it means that Zn left from 0 and it came to 2 plus. What about NO3? Now, NO3 on the side, you have to find the charge for it. Now, N here is X. Always O is 2 minus. So, we have X plus 3 times 2 minus 6 equal to this minus that was here equal to minus 1, and X minus 6 equal to minus 1. When you carry the 6 across, X will be equal to plus 5. Now we have Zn0 plus NO3. Now we have plus 5 minus 6. Nitrogen is 5, oxygen is minus 6. When you subtract, then you have minus. Across the equation son is Zn2 plus NO2. It tells you that Zn left from 0 and it went to 2 plus. Therefore, it has been oxidized. So this is the reduction, and NO3 left from -1 and it went to 0 because when we go back to the previous equation, O here is minus 2, we don't know N. So when you say X plus 2 times 2 is minus 4 equal to 0, because there is no sign here, so we equal it to 0, and it will now be X minus 4 equal to 0. X will be equal to 4. Now when you take this 4 and add it to this 4, now you got 0. So on this side is 0 also. So look at this. Zn left from 0 and it went to 2 plus, so it has been oxidized. NO3 left from minus 1 and it went to 0, it has been reduced. So what you need to do is to balance the oxidation half reaction and the reduction half reaction. So I'll begin with the reduction half reaction. Now this was the reduction half reaction, NO3 minus NO2. So the reduction half reaction will now be NO3 minus NO2. Look at this. How do we balance this? The first thing we do, we know how many of nitrogen is on this side, how many of oxygen, how many of nitrogen is on this side and how many of oxygen, and then balance them. Now, according to the equation, nitrogen here, oxygen, nitrogen, oxygen, we separate them. Nitrogen is 1, oxygen is 3, nitrogen here is 1, oxygen here is 2. So it means that they are not balanced. So what you need to do to balance them is to add water to NO2 and add H plus to NO3 minus. How do we do that? We say add H plus to NO3 minus. So the equation will now be H plus NO3 minus to you NO2 plus H2O. Now look at this. When you add H2O here, O here is 2, O here is 1. So 2 plus 1 is 3. Hydrogen here is 2, nitrogen here is 1. Hydrogen here is 1, nitrogen here is 1, oxygen here is 3. So it means that nitrogen is not balanced. So how do we balance this? We add 2 here. So now looking at this, this is balanced. But the equation cannot be totally balanced when the charges are not balanced. Now, so the next thing to do is to balance the charges. Hydrogen here is plus 1, 2 times plus 1 is 2, nitrogen is minus 1, NO3 here is minus 1, so 2 minus 1 is equal to 1. This side is 0 plus this other side is 0 and is equal to 0. So since indeed this side is plus 1, we must add something on this side that will get rid of this plus 1 so that the whole side will be equal to 0 and this side will be 0. What do we add there? We add negative electron. How do we do this? Say we add E minus here to do that. Now when you add E minus here, this side will be 0